Hello, everyone, and welcome to today's webinar. On behalf of American Petroleum Professionals of Iranian Heritage, APPIH, it's our great honor to start another webinar entitled Scalable Geothermal Energy Potential from Sedimentary Basins and Leveraging Oil and Gas Industry Experience by Dr. Saeed Salehi. Dr. Salehi is currently Associate Professor of Petroleum Engineering at School of Petroleum at University of Oklahoma. Previously worked as a drilling and well engineer in industry. He has more than 10 years academic experience teaching and delivering university and industry customized courses. He has more than 200 articles published in scholarly oil and gas journals and referred conferences. He is a recipient of prestigious awards from the SP, such as SP Drilling Engineering Award, SP Health, Safety, Security, Environmental and Social Responsibility, and SP Distinguished Achievement for Petroleum Engineering Faculty Award. He has leadership recognition as past chairman of SP Evangelist Section in Louisiana. He currently serves as a co-chair, steering and finance committee chair for SP International Conference and Exhibition on Formation Damage Control. His research interests include subsurface energy, both fossil fuels and renewable, such as geothermal energy. Other than interest are geothermal carbon storage, mitigate of surface and subsurface contamination, issues of process safety and environmental protection when developing subsurface energy resources through a combination of experimentation, finite elements, and fluid dynamics modeling, data analytics, analytical and computational tools development. The long-term goal of his research program is to provide viable and sustainable solution for protection of environment and enable sustainable, affordable, and secure energy supply. I would thank Dr. Salehi for accepting our invitation, and without further delay, I'm transferring microphone to him for sharing his presentation. Thank you so much for accepting.
Thank you, Hamiduza, for introducing me and inviting me. And good evening, everybody. Thanks for taking off time, your dinner and your family time to listen to the talk today. Basically, what we are going to talk about today is geothermal energy. I will provide some background on different applications of geothermal, opportunities and challenges. Some of them you already may know, but since I'm not sure about the background that the audience have, I will go over, most of the concepts. Then we will shift to where are we in terms of geothermal energy, or let's say rephrase the question, what's the role of geothermal in energy transition? And then I will focus on talking about sedimentary basins, why we think that they are very attractive for geothermal application. Then we will go over the synergies that we have with oil and gas industry. And then at the last, I'm going to have a case study that we are involved in terms of, using oil and gas wells in the hydrocarbon domain for geothermal applications. So let me go over, some of this main concept of geothermal. So let's look at the left schematic. When people refer to geothermal, sometimes there's a misconception that it's referring to power production or electricity. But in essence, geothermal is much diversified than that. So if you look at this one, for instance, we have technologies like heat pumps. This is pretty mature technology, more than 150 years. And, it's mostly used for residential places or, let's say, small facilities, heating and cooling. We have a very successful application of this in the US and all over the world. And pretty much everywhere in the US, if you drill a 10 to 20 feet well bore, you can get a temperature of 60, 65 F that you can, tap into that temperature for heating and cooling purposes. Then we shift to what we define as hydrothermal, and this is more of a traditional type of geothermal, power production, and it's been mostly used for in the areas that are active in volcanic or let's say have hot formation that, mostly, in the depths of 2 to 3 kilometers, and uh, companies use for generating power, using the power plant at the surface. And then we have a new concept is called enhanced geothermal system, or EGS, which is basically deep injection and production wells. That one well is used for basically fracking, it's the open loop, and then you have basically a production well, that you take the hot fluid to the surface and use the steam to generate power. Right now, the AGS in the R&D stage, if you have heard of Utah Forge Consortium, the U.S. Department of Energy right now is investing in this type of enhanced geothermal system. And then we have also the other type of geothermal, which is a sort of similar to EGS, deep EGS, for the super hot rock drilling. And there is a potential that if you go to depths exceeding 500 C, or let's say, beyond 5 kilometers, 7 kilometers, you can tap a very hot formations. So regardless of what you refer in the geothermal, there are different applications. So if you look at the right illustration here, you can see that, it's not just electricity. You can use it for instance, fish farming, for agriculture, for food processing, fabric drying, for making cement, and then also in the new energy transition domains such as hydrogen production, this can be used. So it's not only the type of geothermal are diverse, but also the applications. So what is so unique about geothermal? Number one, it's a 24/7 dispatchable base load. So unlike solar and wind that you rely on the environment and the condition at the surface, geothermal doesn't rely on that, and it can be accessible 24/7. And then the other beauty about the geothermal energy is is how much surface land footprint geothermal has. So, for instance, if you look at this chart from Department of Energy Geovision report, you can see that the total land footprint of geothermal is significantly less than things like solar. So, for instance, you drive by, the highway, you see these solar farms, or the wind mills. Those are great energy, but one disadvantage is that it's also taking a lot of space at the surface. But unlike these type of energies, geothermal, you're probably going to see a bunch of wellheads and maybe power plants for this. So there is this great advantage for scaling up this type of energy in the US and also in the global basis. Now, having said that, the benefits, we shouldn't forget about some of the challenges. So one of the major challenges for the geothermal energy development is high risk. So, for instance, the exploration, we don't have much tools, to, let's say, spot the hot environments for geothermal applications. The drilling is costly because the rocks are harder, and also the wells are hotter. So, a lot of tools that we have in the oil and gas industry, for instance, cannot be applied. And also, one other thing is the permitting process. So for instance, if you are taking couple of weeks for a permit in oil and gas, this may take 2 or 3 years in geothermal. And you can see a lot of big investors or companies, they cannot wait that long to develop this. So there are a lot of, let's say, progress is currently happening to overcome these barriers, but at the moment we are not there yet. So you can see, for instance, the cost is for a typical geothermal well is usually much higher than the oil and gas because of the same reasons that I talked about. So one other major question is that what's the role of geothermal in energy transition? Okay, we talked about it's great, it's good, it's a dispatchable base load, but unfortunately, geothermal is not in the place that it has to be. So if you look at, for instance, the outlook of the annual energy 2022, you can see we are here at this moment in 2023 in terms of the portion of the electricity generation from different sources, and you can see that by 2050, the basically the portion of renewable is going to increase. But if you look at the breakdown, you can see that most of this renewable is going to be solar, wind, hydroelectric, and look at the let's say the prediction for geothermal, it's going to be around 2%. So 2% is really very small, when you're talking about, the future of geothermal energy. Now, these things are predictions. So there are a lot of, let's say, advancements are currently happening. We are in the geothermal decades, a lot of investment are happening. So this may change, but the reality is that on the paper right now, the geothermal portion is very small. So what we should do to increase this, either we have to increase the number of wells, or we have to reduce the cost, or both of them, or we have to look at out of the box in terms of where to apply geothermal. So if you look at the application of geothermal energy at this moment, it's mostly on Western Hemisphere. So you can see the states like California, like Nevada, they have a larger portion of geothermal. But then when you come to, for instance, places like Texas or Oklahoma or other places, it's very small. So what we should do, it's one of the ideas been discussed, in the past couple of years, is to really expand the geothermal applications in the sedimentary basin. And the beauty is that, sedimentary basins are much more diverse. We have a lot of data, and then we can basically scale up, the share of geothermal if we develop this type of energy in sedimentary basin. So let's review some of the facts, and many of you know about this. Drilling in sedimentary basin tends to be easier and less costly. Right now we are drilling at the rate of 2,000 feet per day, and then we could go to depths of 15,000 feet in 2 weeks, and the cost is getting less and less as we are developing newer technique, new tools. So why don't we leverage this for geothermal application? The other thing is that it has a large diversity of sedimentary basins, so it is not limited to some areas. You can go to Oklahoma, you can go to Pennsylvania, you can go to Texas, and you can still tap these rocks. The other thing is a higher permeability, higher porosity that you have in the sedimentary basins. You don't need to frack much in this type of formations. You can have a natural flow from this type of rocks. And then non-geology, you have hundreds, if not thousands, or more geologic experts in different sedimentary basins that we have been developing more than right now 150 years, and it's a pile of data. We have logs, we have cores, we have information, and then the other thing is we have a know-how of let's say stimulation. We know how to frack these rocks. We collect a lot of test data, and we can leverage this for geothermal application. Now, having said that, the flip side of application in geothermal is that the maximum achievable temperature may be limited. So, for instance, going beyond 150 C is maybe challenging, in some of the formations to reach that. The heat flow questions, so we need to investigate this better, in terms of the R&D to understand, where you can have a better heat flow, because unlike oil and gas, the commodity that you are dealing is hydrocarbon. Here is heat. So heat is also carried by a fluid, basically, hot water. So the heat flow is sort of very important factor here. Thermal conductivity of the rock is, for instance, a very key parameter, and it's low in some rocks. In terms of long-term depletion, we need to study, for instance, if you produced heat from a reservoir for 10 years, how would be, let's say, decline curve every year? These are the data that we don't have because of the number of wells that are, let's say, limited in geothermal applications. And the other thing is seismicity issues. So there are a lot of concerns, about seismicity. Oklahoma is a notorious examples of earthquakes that we had in the past. We have right now a very much in control of for seismicity. We know the science, we know the practice, how to control this. But these are the points that I want to make here that needs further investigation. So just follow up on that. There are several factors that can be important, or let's say in selecting your decision in terms of produce electricity or just use for direct use can be very critical. So higher temperature, are we targeting always the higher the temperature is the better? Not necessarily. Right now we have technologies like ORC, organic ranking cycle, that you can use a temperature of 100 C or 110 C to generate electricity. You don't need to go to 150 or 200 C or 300 C. Maybe the potential is less, but at the same time, you don't need to go that deep. How important is the permeability? We know the higher the permeability is, the better, but then there's going to be a sweet spot in terms of the maximum geothermal production that you can have from a reservoir. What would be the sweet spot for that permeability and petrophysical properties. The same thing goes for TC, the application. For instance, definitely you're going to have different decision tree if you are going after direct use or you are going after the electricity. And then the cost is the holy grail of all these factors. That how much is going to the cost of drilling to get to that depth, and does that really worse the potential outcomes that you develop, or let's say the amount of energy or electricity that you can have from that reservoir formations. So just talking about different types of the applications for geothermal, let's not forget about the great benefits that we have for the direct use. You don't need necessarily have electricity for everything. I mean, the way we use energy is somehow wrong in some places. Instead of using, generating electricity and use the electricity for heating and cooling, you can use directly the energy from geothermal for heating and cooling. Why that? So if you look at this chart that you see on the right side, this is from National Renewable Energy Laboratory for the study that they did recently. And you can see the space and water heating is 65% of residential electricity demand. So basically, 65% of the electricity goes for this. And you can replace some of this, heating by just switching to geothermal without having the electricity to do that. And then the other thing is that, the demand for water is now is critical. We are in the water stress in many places. So geothermal direct use can, help with that. And it's also a very reliable solution if you have a very harsh winter areas. You see the climate is becoming unreliable. Every time we had a disaster during the Christmas day, and then the power facilities getting shut down by environmental disasters. So the great benefit is that with switching to geothermal, because it's underground, we don't have much facility at surface, you can have a much more reliable energy source. Now, talking about diversity of sedimentary basins. So for many of us working in the oil and gas industry, we know permeability and porosity is so, let's say, desirable in many places. Texas Gulf Coast, we've been drilling there for many decades with, a lot of good formations with, high permeability, high porosity. We go back to Oklahoma, go to, East and West Texas, go to New Mexico, go to Pennsylvania. So this is a very good diversity that you can access, basically this formation pretty much everywhere. And then look at the data that we have here, in terms of porosity, somewhere in the range of more than 15%. And then, you have a permeability of around 100 millidarcy in many places. And if you compare this to what we have in granite, or let's say the igneous rocks that we are using in Nevada, for instance, we need to spend a lot of money to simulate that rock to reach the same permeability that we have in Texas Gulf Coast. And look at the map here. Many of you have seen these maps. So this is from SMU Geothermal Labs, and you can see the top one is a temperature at 4.5 kilometer, and the bottom one is temperature at 10 kilometers. So at 10 kilometers, pretty much everywhere in the US, you can produce power, based on the temperature that you see. But you don't need to go to 10 kilometers. If you go to 4.5 kilometers, there are still a lot of hot spots in Louisiana, Haynesville, in Texas, in Oklahoma, that not only you can do the power generation, you can also use it for direct use. You don't need even to go to 4.5 kilometers for direct use. You can go to less than 4 kilometers for that. And one of the things we are doing right now is create a comprehensive geothermal map that we put the cost of drilling, we put the time to reach that formation, and also the thermal gradient in one map. So it can help the decision makers and operators in terms of where are the sweetest spots to invest in geothermal. So that's something we are working on, and hopefully we're going to have this map out very soon. So having talking about earlier in my presentation about the synergies with the oil and gas industry. I mean, many of us know about this, but there are some great benefits that the oil and gas industry can basically scale up the geothermal applications. One is the investment capital and risk management. We are dealing with the budgets of millions of dollars for a lot of our wells. We are used to big risks. We are used to dry wells. What are the other industries that are used to these type of things? There are very few industries that they can manage something like this. And that's exactly what geothermal needs. You need large capital, you need big investment, and there are big risks. So we can, use the same tools, same skills, for geothermal. Again, a technology workforce, skills, okay, the same guys who are running the casing, the same guys pumping the cement, you can basically use the same people, to drill the geothermal wells for you. The assets that we have in terms of, thousands of pipelines in the country, the surface facilities, everything that we have, and those facilities are close to population centers. You can leverage those things for, geothermal applications. If you're using it for direct use, pipeline is so important. You can, sort of use some of the pipelines for this application. And this is also the map of the skilled workforce, and you can see how much of the skilled workforce we have, not only in the Midwest, not only in the, let's say, Texas or Oklahoma or Louisiana. We also have that in, places like California or Denver. There are two other things I have here, which I have circled them green, and these are sort of, I think, new opportunities for us. One is repurposing opportunities. Basically, somebody goes and repurpose the current oil and gas wells into geothermal energy. And I will talk about this later in my presentation with the case study. But there's other thing here. Everybody's talking about the future of energy is going to be hydrogen, or let's say hydrogen is going to be big in the energy transition. How about we use the geothermal power for the green hydrogen production and storage? Think about it. You have a reservoir that you can use it for geothermal, use the same reservoir to have the electricity, then use it for hydrogen, and then store the hydrogen in the nearby reservoir. So basically, you can have all the things in one box, just with the oil and gas industry expertise and skills. Now, a lot of things are in R&D development, so there are things that needs to be researched, but I think we are on the right horizon to get into to, let's say, mastering the energy transition. And it's not just the US. If you go to around the globe, this is a map of, the thermal gradient map at the depths of 4 kilometers. And you can see a lot of hot spots, temperature gradients of 30 to 50 C per kilometer, pretty much everywhere, not only the US. Look at the Europe. There's an energy crisis in the Europe. Why don't you just, switch into geothermal? In many of these places, Africa or, East Asia or wherever you want to have it, you can have it. And that's what I mean about the scale. It's not just going to be limited to have it in Western hemisphere here. You can have it everywhere. And then, we have also a lot of data globally, for the sedimentary basins. So one more slide on the some of the commonalities that we have with the both industries. I think except the financing, permitting, the power plant, regulatory, and exploration that are quite different in geothermal, there are a lot of commonalities. So for instance, the drilling expertise, the tools, the bits that we have developed, right now they are dealing with the PDC. Where was the PDC really developed, or let's say experience? It was in oil and gas. A lot of logging tools that we have are going to be used. Same thing with the fluids. If you go look at the cementing or well construction, simulation, that's all from oil and gas. So honestly, it's just something we have to lead as an oil and gas industry. And without the oil and gas industry, it's impossible to scale the geothermal extraction. You may make it some, let's say, advancements, 1%, 2%, somewhere here, somewhere there. but you cannot go as big as solar and wind. And that's where the geothermal industry needs the oil and gas industry. So some of the things that I want to mention, about the barriers. So drilling cost is high. The average rate of penetration in geothermal drilling is at a good condition is less than 50% of what we have in the oil and gas industry. So getting the drilling cost down is the key. And there are a lot of things we can do right now. There are a lot of investments from U.S. Department of Energy trying to fund a lot of projects for oil and gas technologies to be applied for geothermal. There are also a lot of startups now working on this. But the holy grail is drilling efficiency. So we have to reduce the cost. We have to increase the ROP. We have to be better in the drilling. We have to scale it up. We have to go from 100 wells a year to 5,000 wells a year. So we can, learn from each well. The other thing is well integrity is another thing. So when it goes to high temperature, you're dealing, with monsters, so you're dealing with problems that high temperature creates for your casings, for your corrosions, for your, wellbore stability, everything. So we have to work on this, and there are, solutions out there. It just needs to be demonstrated, or let's say, scaled up. In addition to drilling and wellbore integrity, we need to do a better work on reservoir characterization. The same army of the scientists that work in the oil and gas industry as a reservoir engineer, we need the same army to scale up the geothermal. Now, we have to think a little bit different. In oil and gas, you're always trying to optimize commodities of, let's say, natural gas and oil. Over here, the commodity is heat, and it's carried by, hot water. So there are some tweaks we have to make, but I think we have all the skills, we have all the softwares and tools to do this. Measurement and actuation, high temperature logging is limited. Right now, we can go to 200 C. There are some tools that are promising, so we can, leverage those for higher temperature. The MWD, LWD, we need to sort of improve them for the high temperature. So at that condition, we can, drill a lot of these wells at much lower cost. And then permitting is another thing I mentioned. It takes such a long time right now. But the state agencies right now trying to tackle this. There are a lot of companies pushing this. So I think there are lots of improvements going to happen in the next few years. Some of the technologies that can be applicable, and there are again companies trying to work on to basically demonstrate some of this in geothermal. But managed pressure drilling, such an excellent technology we have in oil and gas. We have increased the ROP so much. Right now, in offshore, we are drilling a lot of wells with the MPD. Basically, you control everything, with this. There's a spot for this type of technology in oil and gas, in the geothermal, sorry. And then you have technologies like, expandables, monobore systems. We have done this in the high temperature, high pressure reservoirs in Gulf of Mexico. Why don't we just take it to, geothermal? Casing drilling, we have been, loss deflation is such a big issue in geothermal, and casing drilling has been applied. It's been, saved a lot of money for operators in the loss zones. There's a potential that you can basically upgrade and then reuse this type of technologies to reduce your drilling costs. So the last piece that I want to talk about here is repurposing opportunities. So you see a lot of these, old wells in your neighborhood, in your, nearby your kids' school, nearby the churches, hospitals. There are large fields that have been producing, for decades. And then, what's the future of these wells? Should we spend 200, 300K more to plug and abandon these wells? Or there is a future for this type of wells? So that's another opportunity. We have spent such a large capital in these wells that they have access to easily temperatures of 100F, 150F, even many places. This is enough for power generation. If you go places like Hainesville, you can go into 300, 350F. Some of these wells are hot. So what's the future of these wells? The future is that we repurpose some of these wells for geothermal applications. And then you can use that energy for powering up small towns. You can power up, many close by facilities and many houses, many other applications, farm facilities, military, you can name it. So if you, for instance, look at the number of the wells, it's not going to decrease. Even in the best scenario of, energy transition, we still need to have a lot of oil and gas wells. So basically, the pile of well, or let's say the number is increasing, and you can see the numbers here. And there are a lot of numbers out there in terms of, how many of these wells are right now, let's say, abandoned or orphaned and non-producing. So there are numbers of around 3 million. I have seen numbers around 1.7 million. One problem is we don't know the exact number, but we know that that's huge. And then look at this number, 1 million new wells currently drilled will be live in the future. So what's going to happen to the well that right now producing from Permian Basin? After 2-3 decades, somebody has to plug it. But there is a better solution than P&A, and then use it for geothermal applications. So these are the two maps I want to show to you. One is from the US EPA, and it's showing the documented orphan wells. And you can see, and a lot of those are located in Midwest, in Texas, Oklahoma, also places like California. This is also a map from Washington Post that is quite a little bit few years old, but showing close to 1 million wells right now we have. And the good thing is that a lot of these wells are in the good quality. So they have been drilled in modern well completion techniques. They may have a better well entry situation, and then they can be leveraged for this type of applications. So some of the benefits, and you already know some, reallocate the P&A cost for repurposing. So instead of spending that capital, get it for geothermal. Extend the life of the assets. So it's going to be revenue for well owners, landowners, and community benefits. The surface landowners can get some royalties for geothermal energy. Why you just leave it there? You can have it for another 3 or 4 decades. Help feed the stability of the grid. Again, I mentioned the environment or the climate is becoming unstable. Many places this can be a backup power, and use it in the emergency situations. Everybody is also talking about ESG, environmental, social, corporate governance. It's everywhere. The investors are pushing, or let's say putting pressure on the oil and gas companies for this. And this is an excellent component for a company that has this type of assets. Okay, this can be repurposed for geothermal. And what can be better than ESG? You just having a meaningful contribution to your community. Some of the items I also want to mention is that there are some conditions for repurposing, or there are some ideal conditions for repurposing. Number one is that your wells should have a good record of casing and cement integrity. Again, this is a different applications. You are not going to produce oil and gas. You are going to mine heat. And then mining heat, you're going to have a lot of loads. So you need to make sure your casing are not corroded, your cement are not bad. And I'm not saying, every well is going to retire, have a good casing and cement integrity, but most of them may have. Depleted fields, so many of these fields that have produced and there is no future for hydrocarbon, this is a very ideal, let's say, field for a geothermal. Close to high population density, agricultural centers, remote operation facilities, military complexes, chemical plants. These are the ideal places that you can leverage for geothermal. And the reason is you're going to spend less money trying to invest in that pipeline, or let's say facilities to take your heat to these, these centers. But the good thing is a lot of these wells are close to this type of facilities. I mean, if you drive in the Gulf Coast, you can see a lot of hydrocarbon wells close to, these petrochemical complexes. Access to pipelines for energy transfer. So if you have, some pipelines, that's going to be beneficial for geothermal. And availability to batch of wells. So single wells are good, But if you have batch of wells, we have done a lot of simulations. If you have 15, 20 batch wells and then are close to 10,000, 15,000 ton, you can have enough energy for that ton. And the other thing I want to mention is about the project that we are doing for demonstration of the repurposing of oil and gas wells. So we have launched a program. It's called HOG, hydrocarbon wells upcycled to geothermal. And the goal of this program is repurpose the current hydrocarbon wells from the test sites that we have to the geothermal applications. So the test site is located at the city of Tutek. It's about 35 miles west of Oklahoma City. And we have found this field with 4 idle wells, non-operating wells, that are close to 3 schools. Actually, there are 2 of them are less than a mile from an elementary and middle school. And we're trying to repurpose these wells for heating and cooling of these schools. So the idea of repurposing on paper is not new. There are a lot of, or let's say papers people publish or talked about this, but the demonstration is sort of new. So we don't have much field data, somebody showing that. So one of the long-term goal of this research program is to show the feasibility and then, have some data proving that, we can use the current hydrocarbon wells for geothermal. So this is the field. You can see a very beautiful creek is between the wells. So there are well 1 and 4 are in distance of 2.5 or 2,500 meters. There are well 2 and 3 in sitting less than 300 feet. And then if you look at this schematic on the right, you can see that this is open field that we are going to use it for, for the pipelines to take the energy from the well sites to the schools. So the concept that we are trying to do is not very complicated. We are trying to temporarily abandon these wells and then go off the oil and gas zone and try to use some of the formation above that have high porosity and permeability and try to recirculate water through the formation, heat it up, and then take it back to surface and then take it to the schools. So, if you think of the practices we do in the oil and gas, this is maybe well construction 101. We easily can do this. We have, the enough, let's say, expertise and skill and, tools to be able to do something like this. So there are a lot of data is going to come out next year or let's say end of this year when we finish this first demonstration in terms of, the injecting fluid and producing energy from these wells and proving the feasibility for the, or let's say for the amount of energy that we want. So there is a sort of promotional video just showing the well information, the well sites, and so maybe I'll be quiet here. So one good thing about our case study is that the wells are not that old and they are in the very good condition. So 3 of them are actually, have an age of around 20 years old. And we have looked at the condition of casing and the cement. They have a depth of 10 to 12,000 feet, 10,000 to 12,000 feet. Very good well integrated conditions. We have a lot of data and logs on understanding the geology, and having done the seismicity simulations, and the risk is very low. So we are hopeful that we are going to have a successful field application. The beneficiaries are again the school students. They are very enthusiastic about this. More than 1,700 students are going to benefit from this. We are going to save 75% of their energy bills once the project is sort of realized, and we are really excited to give back to the community with the help of the oil and gas industry. So sort of project progress, we have kicked it off last year, and then right now we are working with regulators to get the permitting, and we are going to have the first field test in the next couple of months. So I know I don't want to go over time, so I don't have a very specific conclusion, but some concluding remarks. I think the sedimentary formations, the oil and gas assets, is the future of the geothermal. I think it's a huge opportunity for the oil and gas industry, and also for us as a professional, to be able to leverage that for geothermal. I think tech transfer can happen. We have a lot of technologies that can be used, from oil and gas drilling to geothermal. We just need to demonstrate those technologies and reduce the cost that we need to go with the geothermal. The synergy is high. We have the skills, we have the assets, the repurposing opportunity, I think is huge. I think a lot of companies are very interested in this. We have been engaged with both operators, the small companies, service companies. They are very excited to know the outcome of the field test. Having said that, there are some of challenges and barriers we have to overcome. Permitting is a big issue in geothermal, energy ownership, royalty. These are things that eventually we're going to have a solution for, but it's going to be a sort of barrier for us. So just want to mention some good articles published about this work. One was in Works. So if you read that, they have gone over several opportunities for the repurposing oil and gas. There is also a recent article published by Deutsche Welle from Reuters, and they talk about the golden age of geothermal energy, and there are good arguments in the article. So I just reference if you want to read further about these things. Like the acknowledge team, we have got the first place in the Sooners geothermal for the DOE project competition last year. $10,000 cash for the team members of the project, and we have a very diverse team of geophysicists, geologists, drilling engineers, you name it, and all of them are graduate students at the university that are very excited to make this happen. And finally, I'd like to thank Hamid for setting this up. Also our sponsors and our partners, the U.S. Department of Energy, Blue Cedar Energy for donating the wells to us, National Renewable Lab, and Baker Hughes with donating the softwares, and also the CT of the Total for helping us with this project. So with that, I'm sorry if I've gone a few minutes over the time. I'm happy to go over some questions here. So maybe I just look at the chat.
Thank you so much. I received a couple of questions. I'll place it in your chat. Other audience, if you have a question, again, you can send directly to me or type in chat. I will organize it.
Sure. So first question, how do you see the future of geothermal? So I'll probably be a little bit biased about this, but I think geothermal has a big future in the energy mix. And the reason is that there is not much hype about it. It's a domestic energy. It's access. It's real. You have the skill, set to do that. You can, have it accessible, everywhere. And I think, unlike hydrogen, that the cost is high, or you need to have a lot of water, or the storage is going to be issue. Geothermal is not like that. So you can have a diversity for direct use, for electricity. So to me, I think the future is big. I won't be surprised if we surpass the wind and solar, in the next decade with the total of megawatts that we can have from geothermal. What's the main barrier for developing geothermal? I think I have answered some of this in my presentation. I think the main barrier, honestly, is the cost, and also some of these things like permitting, and also the mentality of the people, and the mindset. We have a lot of naysayers saying, it cannot be done, that doesn't have a future. I mean, we need to overcome that negative, let's say, perspective and try to positively think about which country is pioneer. I mean, in terms of total megawatts or gigawatts, US is number one in terms of geothermal, but there are a lot of advantages happening in Europe right now. So I wouldn't be surprised, they surpass us soon. For geothermal, do we need to have horizontal or vertical wells? Again, this is such a diverse thing, right now, most of these hydrothermals are vertical, but there are a lot of technologies working to leverage the horizontal because you're going to have a much exposure, like, hydrocarbon production to the heat. So won't be surprised the future going to be, horizontal geothermal. What's the common time period for an abandoned well to become a potential geothermal well? Well, nobody has done this, as far as I know, in terms of demonstration. But I won't be surprised if, let's say, you have a well that is idle. You could turn this to geothermal in a few months. You just need to do a TNA, then convert surface facility to geothermal, and then have your pumping and everything to try to have the geothermal from there. What's the common time for? Okay, I think I answered that. Okay, good question. So if you have geothermal for electricity generation, what's the price? Again, right now the price per kilowatts of technologies like EGS, because it's not commercialized, we don't know. But for instance, super hot rock drilling, there was a report came out a few months ago, and they estimate that the geothermal kilowatt price is going to be less than natural gas. Now, this is all estimation, but but it's based on the potentials, total megawatts that you can get from one well. For instance, some of these wells, you can get 25 megawatts of electricity to be produced. So you can see it can be commercialized. So we don't have a fixed answer for this yet. If geothermal used for okay, I think I answered the cost. I mean, comparable to wind and solar, maybe right now is more expensive because we don't have much scale like wind and solar, but this is going to change. If you look at the solar 10 years ago, that was very expensive. Everybody was saying, it's crazy to pay this much, but look at now. People are putting solar, on the roof. They're open to this. So mindset is going to change as the cost is going to come down. I don't know if there's any more question, but I'm happy to answer. I can put my email in the chat to everybody. If you want to reach out, please reach out. I would be happy to answer any questions that you may have, and maybe have a discussions later.
Excellent. Thank you so much.